Hi folks, let's take a look at 2C here. So again, we see that we have another reciprocal function, which is the reciprocal of a polynomial. So let's see what it looks like. Let's see if we can go a little faster here. So first thing I notice is this function x squared plus 1 is just x squared. I'm going to be adding 1 to it. So here I'm going to put my x-axis a little lower. Since in fact I'm not going to have any negative values at all. Okay, I'll still keep my y-axis right down the middle since we know that it's going to be a symmetrical function. Okay, and I know that it's going to be x squared plus 1. So again, I'll 1, 2, and here 1, 2. So there's going to be my vertex. Okay, then again, whether you just put in some numbers or do a step pattern, so go up by 1, up by 1. Okay, up by 2, up by 1, 2, 3, 4. Okay, and then it's just symmetrical on the other side. Okay, so let's draw our parabola here. So this is our starting function. Okay, and now let's see if we can figure out what the reciprocal of this function is going to look like. And the first thing I notice is that there are no zeros. Okay, which means there's no value for which the reciprocal is undefined. Okay, so it doesn't look like we're going to actually have any vertical asymptotes here. Okay, so let's move on to the end behavior. So we take a look as x squared plus 1, as x gets larger, x squared plus 1 goes to positive infinity. And so what happens when I take the reciprocal of very, very large numbers? Very large positive numbers, they become very small positive numbers. So we're still going to have our horizontal asymptote at 0, it would seem. And here, as x goes to negative infinity, the y values become very large and positive. So when I take the reciprocals, I again get numbers that are very small, approaching 0. Okay, let's look to see if we have any invariant points, so values where the original function is equal to 1 or negative 1, which would produce the same number in our reciprocal. And we see that there's only one place where they share the same number. Okay, so what's happening in between here? Well, we notice here that this is the smallest number we have. When we take the reciprocal of 1, we just get 1. But all the other y values are larger than 1. So when I take their reciprocals, they're all going to be smaller than 1. So it looks as though this is actually going to be the x value that's going to have the largest value of y. Okay, for this one here. So it looks like my function is probably should have made it a little curvier, is going to look something like this. Okay, looks a little better on the right hand side, but it should be getting larger, 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 eventually getting to our maximum value, and then all the subsequent ones are all going to be smaller than 1, but still remaining bigger than 0 and getting closer and closer to 0. Okay, so here we see how a reciprocal function doesn't need to have a vertical asymptote. Okay, so since there was no zeros, I just went on to the other things. Look at the end behavior of the original function to find the end behavior of the reciprocal. Look at the points that are invariant, in other words, the points that they share, and then from there, see if you can intuitively determine what the shape of the rest of the function should look like. Okay, that's it for this one.